All right, so we're still in 1.4, looking at multiplying complex numbers. Read some of this stuff. So we have 4i times 3 minus 5i. So we want to distribute this the same way we would as if it was a regular number that we were distributing. So 4 times 3 is 12i. And then, yeah, 4i times 3 is 12i. And then 4i times 5i is 20i squared. So make sure you don't leave off any pieces of your terms. 4 times 5 is 20, I times I is I squared. Now, when you're dealing with the simplification of your expressions, I squared should never be a part of your final answer. Reason being is because of this right here. We know that I is equal to the square root of -1. But if I were to square that, the square and the square root would cancel, which would leave us with -1. So really, I squared will always reduce down to -1. So even if you don't remember the process, you don't have to hold on to the process, but you do need to remember that I squared is equal to -1. That will always be the case. So that means we have 12i minus 20 minus times -1. That -1 times -20 will be a positive 20. And then when you're talking about standard form, your real part is always written first, imaginary part is written second. So if I'm not mistaken, my math lab does hold you to the standard form. In other words, if you will put imaginary part first and then the real, I believe it will say right in standard form. But if not, then I mean, it's all good. But standard form is the real part first, imaginary part second. All right. And always, if I scroll up too fast, let me know. Next one is 7 minus 3i times -2 minus 5i. So we have our binomial distribution, 7 times -2, 7 times -5i, -3i times -2, -3i times -5i. Negative times a negative turns positive. Somebody asked, why did the subtraction turn to addition? If you're talking about that last one, -20 times -1 turned to positive 20.
Wait, could you explain how we're distributing that again?
You talking about the one down bottom?
The 7 minus 3i.
Yep, 7 times 2, and then 7 times 5.
Okay, only distribute the 7.
Mm-hmm. So you distribute each term into the other set of parentheses. So you distribute the 7 times the -2, 7 times -5i. Then you distribute -3i times -2, then -3i times -5i.
Okay. Wait, why are we distributing 3i? Is it because of the I?
No, it's because it's in the parentheses. Same thing as if I had x plus y times a plus b. I would distribute x times ab.
You would distribute both the x and the y?
Right. It's the same thought process. Yep.
Okay.
All right. So we combine our like terms in the middle. We have -35i plus 6i, which would give us, this 29 right here, -29 right here. And then, like I mentioned in the last problem, I squared is going to give us -1. So that's 15. So that'd be -15.
Just a quick question.
Yep.
Maybe I'm getting ahead, but what if the I is to the power of third or the fourth or the fifth?
That doesn't happen for you guys in this sec. They used to teach that, but they don't emphasize that anymore.
I remember like learning about this back in high school, so I was like, what if that happens here? I just want to.
Yeah, it's not it's a repetition every fourth You know, for every fourth power, there's a repetition. It goes from I squared, which is -1. Then I cubed is -I.
Yeah. I remember that. I cube and I square is 1. I to the fourth is 1.
Right. And it
Yeah.
keeps repeating that pattern. Yeah. But like I said, though, they really don't emphasize that much anymore. So you're not going to see that in this section.
Oh, okay.
All right. All right. So then we have -14 and -15, which will add together, give you -29. Minus 29i as a final or most simplified expression. So once again, guys, you don't have to worry about this. That was something he was asking about, but that's not going to appear in this section, so you'll be all right. All right. So matter of fact, I'm gonna go ahead and erase that because that might mess up future notes. Somebody else might like, why is that up there? All right.
So I squared will always be -1.
I squared will always be -1. Yep. All right. So the next thing is our complex conjugate. If you have a plus bi, the complex conjugate of a plus bi is a minus bi. So basically all you're doing is changing the sign of the imaginary part. So there are a few examples of complex conjugates. 5 plus 3i and 5 minus 3i. -8 minus 11i. -8 plus 11i. Then 23i and -23i are all complex conjugates of each other.
Can I ask something?
Sure.
The sign in the middle changes.
What about the sign in the middle? I missed the first part.
So for example, like why -8 doesn't change into +8?
Right. It's just the sign of the imaginary part.
Oh, okay.
Mm-hmm. Oh, what's going on? Okay. All right. So the reason why that is important is because when we go to divide, you're going to have to multiply top and bottom by the complex conjugate of the denominator. All right. So in this one right here, we have 3i over 4 plus I. And that means we're going to multiply top and bottom by 4 minus I, the complex conjugate of the denominator. All right. So that's what we're doing right here. 3i over 4 plus I times 4 minus I over 4 minus I. And I got the work down there in the light blue. Give you guys a chance to copy before I get down there though. All right. All right. So here we have our numerator, 3i times 4 minus I. All you do is distribute 3i to each term. 3i times 4. Somebody asked why we switched to 4 minus I, because you're going to multiply the opposite sign or the complex conjugate of this denominator right here. That's what we multiply top and bottom by. That will always be your standard if you're going to divide.
Just a quick question. How did you get, like, when we were multiplying here, the conjugate, the complex conjugate, how do you get 3 plus 12y over 17?
Well, that's what I'm about to get to.
Oh, okay, okay. I'm
Yeah,
sorry.
yeah.
Sorry.
Oh, no, you're fine. You're fine. Somebody else asked the same question in the chat.
I thought you were talking about the 3i times. Oh, okay, okay, okay. I see how you do it.
You're good. You're good. So yeah. So let's walk through the light blue. The light blue is how we get to the dark blue. So the first thing we have is the multiplication of the numerator, and that's down here by the end. So we're looking at 3i times 4 minus I. So we're going to distribute the 3i to each. So 3i times 4 is 12i. 3i times minus I is 3i squared. So once again, though, we have this I squared, which we cannot hold on to. That turns into a negative. So negative 3 times negative 1 is a positive 3. And remember, we want to write the real part first, then the imaginary. So that'll be 3 plus 12i. So before we go to the denominator, questions on what we did there. And so, like I said, we're not here yet. We're just looking at the numerator. 3 plus 12i. All right. So now going to the denominator, we have 4 plus I times 4 minus I. And you'll notice what happens here when we multiply by conjugates. We got 4 times 4, which is 16. 4 times negative I is negative 4i. I times 4 is 4i. I times negative 1 is negative I squared. So what happens when you multiply conjugates, which is what we needed to happen, is that 4i and negative 4i will cancel. And so that's going to remove the I in our denominator. And that's what they consider dividing by complex numbers. So now the imaginary part is gone. And don't forget, I squared is negative 1. So 16 minus negative 1 is now plus, so that'll be 17. All right. So questions before we put our numerator and denominator together? All right, going up here to the dark blue. Our numerator was 3 plus 12i, denominator was 17. And then when you want to simplify or write this in standard form, you do break it up. Put 17 under each term. So that's 3 over 17 plus 12i over 17 for our final answer. Let's make sure we're okay. Before somebody asked, would it be counted as a correct answer if it's not broken up? I know in the past they didn't count it if it wasn't broken up. So to be on the safe side, you would go ahead and write 3 over 17 plus 12i over 17 because you have a real part and then you have a separate imaginary part. Now, if you type it in, if you type it in like this and my math lab accept it, then that's fine. But, doing your homework, that's when you would take, figure out, okay, what type of answers do they, will they accept, will they not accept, so that's what your homework is really for. Once you get your answers, what form do they want your answers in? What's the most simplified form do they want your answers? And so, you can always try it out, see what my math lab will accept. I know for a fact this answer right here is acceptable. They may take this, may not. And if not, in the homework, it'll give you a hint or it'll say, can be broken up or simplified or wrote with standard form or something like that. I just know before they didn't, but no programs change all the time. All right, everybody good with that before we go to the next one? All right. So the next one is just re-emphasizing the relationship of square root of negative. Before you simplify or calculate, take the I out first, or in other words, at least acknowledge the existence of that square root of -1 before you go and start doing things. Because what can happen is if you do not do that, you could lose the relationship or the existence of that the square root of -1 in your calculations. So in the green, we have an example of that. Do it the wrong way first, then I'll show you the right way to do it. So we have the square root of -25 times the square root of -4. Whenever you have the square root of values, you want to multiply them together, you can always multiply what's under the radicals before you actually apply the square root. So -25 times -4 is positive 100. Square root of 100 is a positive 10. So that's actually incorrect in how you would do this. So if we lean on what I said, initially, you want to take out the I first. So I'm gonna do this two different ways. If I just took out the square root of -1, which is I, that would be I square root of 25 times I square root of 4. Multiply those two together. I times I is I squared. And then the square root. What you over there laughing about? Are you laughing at me, Miss Roundtree? Are you good? Okay, I just want to make sure I wasn't saying nothing crazy. And then the square root of 25 times the square root of 4 is 100. And so I squared is -1, then the square root of 100 is 10. So notice how you're supposed to get square root of, not square root. Notice how your final answer is supposed to be -10 versus positive 10. So that's what I'm talking about as far as taking that I out first.
I have a question.
Yes.
Where is the I coming from? Is it just because it's a negative number?
Because it's a negative under the radical.
Okay.
Yep. That negative under the square root will always produce an I. And so that's why you have to acknowledge that before you do calculation, because like I said, in this one, you can actually lose the existence of that square root of a negative if you're not careful. Yeah. Somebody said something in the chat. Oh, okay. Yeah, word. Okay. So now, looking at that same one, if you wanted to, because you can take the square root of 25 evenly and the square root of 4 evenly, you could have broken them all the way down to 5i times 2i. If you decide to do that, 5 times 2 is 10, I times I is I squared, and then that still simplifies to -10 though. But the main thing is that you want to make sure that you do recognize the square root of -1, which is I, before you start doing a whole bunch of calculation, because you could lose the fact that you had the square root of -1 in there. All right. Questions before we go down? Make sure we're good. All right. So let me erase some things. Just look at the black right now. Don't worry about this red stuff. We're gonna talk about that in a second. But I want to erase this stuff so we can walk through it together. All right. So we're looking at the square root of -18 minus the square root of -8. So what we want to do is break down each one of those terms individually before we can add or subtract them. In their current state, we cannot add them or subtract them from each other. Yeah, I'll go ahead and go to the red. So we look at what's going on in the red. In order for me to be able to add or subtract these terms, they have to have the same index on the radical. In other words, square root, cube root, fourth root have to have the same index, have to have the same radicand, and that's what's under the radical. So you can't have the square root of 2 and the square root of 5. Can't add those two together. And if one is imaginary, one is real, you can't add those together. We already talked about that. So when we look at this first one, 5 square root of 2 plus 3 square root of 2 is going to be 8 square root of 2, right? They have the same index on the radical. We look talking about the square root, had the same thing under the radical, which is 2. If anything is changed, you cannot add them together. So when we look at this right here, 5 square root of 2 plus 3 square root of 7, I cannot add those together because one has a square root of 2, the other one has a square root of 7. This next one, 5 square root of 2 plus 3 cube root of 2. One is the square root of 2, one is the cube root of 2. I can't add those together. And then in this last one is imaginary, one is real. Cannot add those together. So I just want to make sure we're okay on what we can add and subtract from each other and what we cannot, because of, you know, the different details or elements going on in our terms.
So it's not the, because like, you know, it has to have the same number underneath the square root, and it can't have anything like negative cube root or 3 to the 3i or 3i square outside.
Well, it can. It's just that if you're going to add them, then they have to have the same elements.
They have to have the same elements. Yeah,
Right, right. So if one is imaginary, then the other one has to be imaginary in order to add them
If
together.
it's different, you cannot solve it.
Right, right.
Okay,
right.
if it's different, you just stop right there and just say no solution.
Well, you would say it's in its most simplified expression.
Okay.
Yeah, it's as simplified as much as it can be. Yeah.
All right.
So if that occurs and, you know, we simplify both of these terms as much as possible, if this happens, then great. We go ahead and simplify it to a single term. If not, then it's simplified as much as possible. And then we'll go from there. Oh, well, it's not erasing. Okay, there we go. All right, so looking at the square root of negative 18, we can break that up into negative 9 times 2. Negative 9 times 2 is still negative 18. Take the square root of negative 9, that would be 3i, and then you will leave the 2 under the radical. Square root of negative 4, we can break up into negative 4 and 2. Negative 4, square root of negative 4 is 2i, and then we leave the 2 under the radical. Questions on those breakdowns before we bring them together? So we look at the purple. That first term simplified to 3i square root of 2. Second term, negative 2i square root of 2. So 3 minus 2, excuse me, it's going to be 1. So that'll be 1i square root of 2. In other words, just I square root of 2. Or if you want to write it as square root of 2 I, that's fine. Just make sure that the radical doesn't extend over that I, because a lot of times people make that mistake. And it still be the same answer. All right. Questions before we get to the next one? All right, so next one, we have negative 1 plus square root of negative 5 squared. All right, so the first thing I did was, you know, took note of the square root of that negative, and so I turned that to I. Also, remember, whenever you're squaring a quantity, you cannot square each term individually. It has to be expanded in this way. So that's negative 1 plus I square root of 5 times negative 1 plus I square root of 5. You're squaring the whole quantity. So what that means we can do, though, is we'll distribute binary redistribution. Negative 1 times negative 1 is positive 1. Negative 1 times I square root of 5 is negative I square root of 5. I square root of 5 times negative 1 is negative I square root of 5. And then multiplying I square root of 5 times I square root of 5. I times I is I squared. Square root of 5 is 25. All right. Somebody in the chat. Can we use a square root of 2ab for the formula? Yes, you can. Yep, you can use that. All right, so we can combine our like terms. Negative I square root of 5 times, not times, but minus I square root of 5 will be negative 2I square root of 5. Got negative 1 in front of both of those. Negative 1 is negative 2. Then here, I squared is that negative 1, and then square root of 25 is 5. Then we can finish it off, combine our like terms. Negative 5 and that 1 is 4. Negative 4, excuse me. As a final answer, negative 4 minus 2I square root of 5. All right, questions? Any questions? All right, scrolling up.
Professor Tucker,
Yes, sir.
I got a question.
Yes, sir.
Go back up. Can you square a square?
Can you square square? Yep, square is 4. Yep, a square to the square. If you talk about, I'll give my pen back. X squared squared, x to the 4.
Could you do that for the problem?
How so? What you mean?
The square root of negative 1 plus the square root minus 5.
So I'm saying, so what are you asking though?
Wouldn't that eliminate the square?
Now, if you're talking about take the square root of that,
Mm-hmm.
you're talking about take the square root to eliminate the square.
Yeah.
Oh, no, well, you need, with mathematics, whenever you want to do something, you need something that's going to be able to offset what you have. So we can't do that in this case because we don't have another side of an equation. In other words, if I had negative 1 plus or minus, not plus or minus, but let's say equal to 5. Because I have an equal sign there, then I can take the square root of both sides because that square root of one side offset the square root on the other side. You see what I mean?
Now, how would that affect the negative 5 in the square?
It wouldn't. It would just cancel out the square right here.
Okay.
Yep. And you'll just be left with that expression, negative 1 plus square root of negative 5.
We go and solve it from there.
Yep.
Just subtract the 1 from the 5. So our answer would be I square root of 5 minus 4.
Well, let's do this.
Maybe I'm thinking too hard.
No, you're just moving ahead.
All right.
Yeah, we're going to get there. Yeah.
We're still on 1.4, right?
Yeah, this is the last problem in 1.4.
Okay.
But what he just asked about was in 1.5, actually.
Okay.
Yep.
I never saw it with a square root.
I
I don't see problems in there with a square root.
You talking about 1.5?
I don't remember seeing a problem with a square root.
In 1.5?
With a square.
That's what I'm saying. You said you talking about in 1.4 or in 1.5?
I think it's in 1.5. I'm not sure.
Yeah, that's the square root property.
All right.
Yeah, that's the second method of solving your quadratic equation, square root property.
I jumped ahead. My bad.
No, you're fine. You're fine. So here, the last one in this section, negative 25 plus the square root of negative 50 over 15. So the first thing you want to do is to break down that square root of negative 50. So that's what I did here over on the right side. So I broke up negative 50 into negative 25 times 2. Take the square root of negative 25, which is 5i. And you leave the 2 under the radical. And so that will bring back into the problem over here. And that'll give us this expression, negative 25 plus 5i squared is 2 over 15. Then to simplify it further, take the 15 into each term. That'll be negative 25 over 15 plus 5I squared root of 2 over 15. And then reduce it by 5 in each case. That'll be negative 5 over 3 plus I squared root of 2 over 3. All right, chat. Yes, divide it by 5 in both cases, and that should reduce for you instead of separating. No, they still want you to separate those. Separating doesn't have anything to do with the reducing. It has more to do with, in this case, when you're dealing with complex numbers, the separating has something to do with you writing it in standard form. So now, if we didn't have imaginary numbers, then you wouldn't have to necessarily separate, but we're separating to write it in standard form. And that's just a standard form. It has nothing to do with calculation. That's just the form that they want complex numbers written in. So that's why you have to separate it. But if this was a Y instead of an I, then you could have left them together and just reduced by leaving them together. Yep. All right. Anything else? Anything else? All right, so before we start, okay, there was somebody in the chat. Oh, why is this here? Okay, good. So we broke down negative 50, square root of negative 50 over here. And so that's negative 25 times 2. And you break it up because you want to be able to take at least part of the square root, take the square root of at least part of 50. And 25 as a factor of 50 was the only thing we could take the square root of, or the largest number we could take the square root of evenly. So the square root of negative 25 gave us 5I. And we left the 2 under the radical. And that's what we have here. Then we broke it up by dividing the 15 into each part. That gives us negative 25 over 15, 5I squared root of 2 over 15. And then we reduce both of them by 5. All right. So everybody good before we start? We're gonna start 1 to 5. Just initiate it, do a couple topics in there, and then we'll close out. Everybody good before I scroll? All right. So 1.5 is quadratic equations. Our general form is ax squared plus bx plus c equals 0. So main differences between what we dealt with our linear equations is that we're going to get 2 solutions, and we're dealing with a second degree polynomial. Second degree polynomial will give us or yield 2 solutions. Highest exponent is 2, so we should get 2 solutions. All right, give you a chance to copy that. In this section, we're going to have 4 different methods that we can use to solve your quadratic equation. First one is the zero factor property. Second one is square root property, which is what Mr. Coley was alluding to, maybe without knowing it, but that's where he was going with.
Hey, Professor,
Yes, sir.
I got a question.
I got you.
About this section.
Mm-hmm.
You're always going to be looking for X. Do you ever have to look for Y?
It depends on what the unknown variable they give you. Because if Y is the variable that they give, then you would be looking for Y. If they put A or M or N, then that's the variable you would be looking for.
I remember you in the past teaching that sometimes you have to look for your points, like point X and point Y.
Oh, well, that's when both variables are involved. in this case, we're only gonna have one variable involved.
Okay.
Yeah, you're talking about, yeah, you're talking about something else. Yep,
All right. Thank you.
not a problem. So the third one is completing the square, and the fourth one is the quadratic formula. All right. So let's look at the first method. The zero factor property. Underline zero and factor because those two words are very key. If you want to have one side set equal to zero, and the way we're going to solve is by factoring. So if you haven't seen factoring in a while, or you're a little bit weak in it, there's only, like I said, there are 4 methods in this section. They only spend a quarter of it talking about the zero factor property. So that means they're not sitting in here, focusing on the factoring principles. So if you're weak in factoring, make sure you get with me, shoot me an email or something. If we need to meet outside on Zoom, that's fine. Or if I need to shoot you videos of me discussing factoring in the past, I can do that as well. But just know that this section doesn't, focus on the factoring process. So it says if A times B is equal to 0, then A is equal to 0, B is equal to 0, or both. So just a light example of the process and what we're trying to get to. You will have a trinomial or maybe something more involved, and you want to break it down into this form, x plus 5 times x plus 2. In other words, you want your expression to be factored as much as possible. If it's factored as much as possible, then you can set each expression equal to 0, and then solve for x, and then you have your multiple solutions. So we had x plus 5 and x plus 2, set them both equal to 0. That'll give us x equal to negative 5 and x equal to negative 2 as solutions. All right. Questions? Any questions? All right, so first one, we have 4x squared minus 2x equal to 0. So we want to factor this as much as possible. We can factor out 2x from each term. Don't forget, if you are to factor an expression, you can always multiply it back out, and it should give you what you originally had. So if I were to distribute that 2x back into the expression, it would give me 4x squared minus 2x. Once you factor as much as possible, then you can go ahead and set each part equal to 0. And those would be your two solutions. 2x equal to 0. Divide both sides by 2. X is equal to 0. And then 2x minus 1 equal to 0. Add 1 to both sides, then divide by 2. X is equal to 1/2. All right. Questions? Any questions?
Yeah, I have a question.
Mm-hmm.
Okay, so you know how you go from the 4x equation and then you go from the 2x parentheses 2x minus 1.
Mm-hmm.
Where did the 2x come from? Because there's two 2x's.
Yep. So you have 2x that's involved in both of those terms. When you pull 2x to the outside out of both terms, what's left is what's in the parentheses. So 2x times 2x gives me 4x squared. And then 2x times 1 gives me this 2x back here.
Okay, thank you.
Okay, no problem. All right. So let's look at this next one. 2x squared plus 7x equal to 4. First thing you should do is to set one side equal to 0. when you know, remember when we had before, we already had one side equal to 0. But if I'm going to use the zero factor property, I need to make sure one side is equal to 0. In this case, it wasn't, so I subtracted 4 from both sides. All right. So now we have 2x squared plus 7x minus 4 equal to 0. So we need to factor this expression into 2 sets of binomials. Now, if we have a minus sign back here, that means that our signs in our parentheses should be different. And also, we're looking at this 2x squared. Factors of 2x squared, just 1 and 2. So we have no choice but to do 2x times 1x. Then when we look at 4, we have our factors of 1 times 4 and 2 times 2. So those are our choices to put back here. And so I did 1 and 4 because remember, we're trying to get 7 in the middle. And if I were to multiply this expression back out, 2x minus 1, x plus 4, it would give me this expression right here. So don't forget, what you would do is just distribute. And so when you do that, you'll get your trinomial back.
Professor?
Was that a question?
Yeah, sorry. The top where it's 2x squared plus 7x equals 4, is that like, what is that when you're,
Well, this was the original equation,
uh-huh.
and they just tell you to solve. So if we're going to solve using the zero factor property, then I need to set one side equal to 0.
So that's why you changed it to -4?
Yes. Mm-hmm.
Okay.
Yeah. There's a -4 there just because, or you just have to fact. Well, the -4 is there. Somebody else is asking about a -4 in the chat. This is what we have, and if I want to set this side equal to 0, I need to subtract 4 from both sides so that that 4 can cancel out and leave me with 0 on that right side. And so now the -4 is over here, but it happened because I had a positive 4 on the right side of the equation. So once we factored, that's 2x minus 1 equal to 0, x plus 4 equal to 0, and you solve them accordingly. For 2x minus 1, we will add 1 to both sides, divide by 2. That'll be x equal to 1/2. And then for the other one, you subtract 4 to both sides.
Just a quick question, Professor.
Uh-huh.
We have the choice to pick which method we want to use, right?
It depends on, I think in this section, I think they might emphasize for a couple of problems, they might emphasize zero factor property. Then, you know, in each one they'll emphasize it, and then eventually it'll just be like solve. So if it just says solve, then you get whatever, you do whatever you want to do. But I think initially they're going to emphasize the methods. Yep. All right, so the next one, we have x squared minus 13x plus 36 equal to 0. So 0 is already on one side. We have x squared, so the result or the factorization of that would just be x and x. Then you want the factors of 36 that will add together and give us 13, because remember we have a positive sign in the back right here, so that means both of our signs will be the same. And then that first sign tells us they both should be minus. So we look at your factors of 36, you got 1, 36, 2 and 18, 3 and 12, and 4 and 9. So we use 4 and 9 because those are the two numbers that will add together and give us that 13. And once you factor, set both equal to 0 and solve for x. Add 4 to both sides and then add 9 to both sides. All right. Questions. I think we got one more. Yep, one more to do. All right, let's scroll up. All right, so we have 9x squared plus 9x equal to -2. All right. So once again, we don't have 0 on one side of the equation, so we need to set one side equal to 0. And the way we'll do that is by adding 2 to both sides. 2's will cancel on the right. And that leaves us with this expression right here. 9x squared plus 9x plus 2. So now we need to factor that. Now both signs, well, the back sign is positive. That means that both signs are going to be the same. And then that front sign tells us to use both positive signs. So now, when we look at our back number, we have a 2. The only factors of 2 is 1 times 2, so that's what we used in the back. Now, when it comes to 9, we have 1 times 9 and 3 times 3. So I decided to go ahead and use 3 times 3. Remember, because we're trying to get 9 in this middle right here. And remember, you can always check it. So I went ahead and did the check here. 3 times 3, or 3x times 3x give me 9x squared. 3x times 2 will give me 6x. 1 times 3 is 3x. 1 times 2 is 2. And so you see 6x plus 3x gives me the 9x in the middle. So that's what we're talking about. When you do this factorization, you can always know whether you have the right factorization or not, because you can always check it by going back and multiplying it back out. And you should get what you originally had. Well, that's if it's the correct factorization, I should say. All right, questions before we look to finish it off? Once you factor completely, you go ahead and set each part equal to 0, 3x plus 1, and 3x plus 2. So on the first one, subtract 1 from both sides, then divide by 3. And then 3x plus 2, you're going to subtract 2 from both sides, divide by 3. And those will be your two solutions. All right. Questions? Any questions? So what time is it? 1:40. So I think we let out 1:45, right? You know what class goes to?
So instead of factoring, can we just use the quadratic formula?
Well, yep. And that's what I believe your other classmate was asking, if what are you held to these methods? What's going to happen is, if I'm not mistaken, as the section progresses, you'll have a certain part of the section that's going to hold you to solving using the zero factor property. So it may ask you a specific question about factoring or something like that. Then the next section is going to do square root property. Next section, completing the square. Final section would do quadratic formula. And then after a while, it's just going to say solve. So if it just says solve, you use whatever method you like. Yeah, but they just emphasizing each one of the methods. And then from there, like I said, you'll be able to do whatever you like. And the quadratic formula will work on whatever scenario you have. So that will always, as long as you know how to do the quadratic formula, once we get past this stuff, as long as you know how to do the quadratic formula, The other methods, you know, are just if you want to use them. Yeah, quadratic formula will work no matter what the scenario is. All right. So before we close out, any other questions? Any other questions? So guys, don't let me forget to start with the square root property for your class. My other class, I got to here. I got to complete the square. So I don't want to start here for you guys because I'm flowing with what I did with the last class. So just keep that in mind. If I jump to completing the square, make sure you stop me so we can do square root property. All right. Any questions before we close out? Everybody good? So try the stuff out. See if you get stuck. Like I said, we're gonna have a review day before it's all said and done. Before we, close out and go into chapter 2, we'll have a review day. If a review day flows into 2 review days, I mean, so be it. But that will be dependent upon you and your questions. Outside of that, if you can't wait till a review day, feel free to shoot me that email so we can set up a time to meet with you individually. Or if you got a study group that you got going on, it's like 4 or 5 of you, and 4 or 5 of you want to meet, we can do it like that as well. I don't, it's up to you guys how you want to handle it. Other than that, if you guys are good, I'm good. And I will see you next class.
Thank you, Professor.
Thank you, sir. You have a good
Bye.
one. Everybody
Thank you.
take care. Take care.
Thank you.
Thank you.